Hello and welcome to today's class. For this class, we'll look at the concept of periodicity in chemistry. So, by definition, what is periodicity? Before we look at definitions, many students find it difficult to understand the concept behind periodicity. After this class, you will really understand what we mean by periodicity and how you can really understand it when you see some certain kind of questions involved in the study of periodicity. First things first, let's define periodicity. By definition, periodicity is the repetition of properties or characteristics at regular interval or in a repeating pattern within the periodic table. That is how you define periodicity. It is simply the repetition of properties, right, or characteristics, right, at regular interval or in a repeating pattern within the periodic table. Now, first things first, what do we mean? If I'm to explain the idea behind periodicity for you properly, we said it is the repetition of properties or characteristics at regular interval, right, within the periodic table. What do I mean? So let's take a few examples to further explain and expatiate what we mean by that definition. Now, if it goes back to your periodic table, right, in quotes, I will display a periodic table on the screen here now. The first element periodic table will display on the screen. Now, this periodic table you are seeing on the screen, if you observe properly, check for hydrogen, lithium, sodium, and potassium. So for hydrogen, look at this. For hydrogen, H, right? For lithium, and for sodium and also potassium, K. Please, if you observe this hydrogen, lithium, sodium, and potassium in the first element, you observe that these four are having something in common, right? What are they having in common? These four atoms here or four elements here are having something in common called one valence electron. So hydrogen, lithium, and potassium are having what the and sodium are having what the one valence electron. So what do we mean by valence electron? So a valence electron are simply the electron present in the outermost shell of an atom. So the electron, so it more of like saying if I draw my shell, K shell, M shell, so the last electron, right? And then in any case, that last electron of any atom is called what the outermost shell. It is called the valence electron. So if I to draw the shell for hydrogen, draw the shell for lithium, sodium, and potassium. If I draw the shell, you observe that the last shell for each of them will be having one electron last. So one electron exists in the last shell of all these four. So because of this similarity between these four, it means they possess periodicity, the repetition of properties or characteristics. So what's the characteristics here? They are having one valence electron, one valence electron, also one. Because they are having the same thing similar to each other, it means they possess what the periodicity. So I can come and say that hydrogen, lithium, sodium, and potassium possess periodicity. Why? Because they they, they all have one valence electron present in their outermost shell. That is basically the idea of periodicity. Also, as I displayed earlier, the what's it called? The periodic table. So you can take your time to pause that video, the one I showed you. So you can just quickly sketch out the table so that as I'm talking, as I'm giving examples, you can check the table as I'm showing you some stuff here. Also, if you observe properly, if you observe oxygen and sulfur are having six um valence electron also in their outermost shell. So if I should draw out oxygen, K and N, so that's 2, and then I'll complete with 6, right? If I draw out oxygen and sulfur, their last electron, that last circle you will draw for oxygen is having 6 electrons there. Also for sulfur, that last circle we are drawing also contain what there 6 electron, because they are having 6 electron in the atomic shell. It means they are having some similarity within them. So it means that oxygen and sulfur are having a similarity of 6 valence electron in their atomic shell. So therefore, I can say that oxygen and sulfur possess what their periodicity. That's the concept. That's the concept of periodicity. That's the concept, right? Also, let's say I have um also let's say I have my line straight, manageable. So let's say I have helium, helium, neon, and also argon. These ones here, this helium, neon, and argon are called noble gases, right? They are called noble. Please note they are called noble gases. When we get there, we'll try to explain these stuffs. So this one are called noble gases, by the way. So that's by the way, please. Our focus here is this: what is similar to them? What's common to them? If you observe there, this the common thing here is that um their their outermost outermost orbital or outermost electron are completely completely filled. If you observe very well, we said for I'm sorry please. We said for complete filled electron, for an atom or an electron to be completely filled, we said the question is two, right? It must be either duplet or octet configuration. So for an atom to be stable, it must be either duplet or octet configuration. By duplet, we mean it must possess 2 valence electron for it to be stable or to be completely filled. And by octet, we mean it must have 8 valence electron. By 8 valence electron, we mean it will possess what the 8 electron atomos shell. So if the atomos shell, if the last shell is having either 2 or 8, it is completely filled. So it means that helium, neon, and argon they have what the a completely filled electron. So in that case, they have similarity within them. So I can see that helium, neon, and argon possess periodicity. And what do we mean by periodicity? It is the repetition of properties or characteristics, right? At regular interval or in a repeating pattern within the periodic table. That's how we define, and that's the basic concept behind periodicity. Also, if you observe also if you observe sodium, observe magnesium, and also observe aluminium. These three here, these three possess three shell each. So if you observe that, if I draw out the shell, we have K shell, M shell, and N shell. My goal here is not to focus on only electron. For everything here, I was focusing on what electron. Now the case here is different. If you observe sodium, nitrogen, and aluminum, if I draw out their shell, they are 3. So it means that sodium contain Kl and M shell. Magnesium contain Kl and M shell. Aluminum contain Kl and M shell. For this similarity, they are called what the periodicity. Why? Because they possess a repeating pattern. They have a property common between them. That's what 3 shell each. So I can call this what this I can say that these three undergo periodicity. This is how you find the concept of periodicity, as I explained. All right, note this, please. Note, please. Note the physicochemical properties, the physicochemical properties of an element depends on the electronic configuration of its atom. I said the physical chemical properties of an element depends on the electron configuration of its atom. So what do I mean? I said the physical chemical properties, the physical chemical properties, those chemical properties that you can see, right? So we said the physical chemical properties of an element depends on what the electronic configuration of its atom. So for me to spot out the periodicity of H, L and I and K, H, L, sodium and K, I had to check for what I can see, and that is what the electronic configuration. So I use the last shell which is under, so that last shell, the KLM shell is under the concept of what under the concept of electronic configuration, right? It's under the concept of ethnic configuration. Because of that, I could see it. So it's more like saying the physical chemical properties, those chemical properties that you can see, such as one plus electron, six plus electron, and whatever there. So those things I can see, we said they depends on what the ethnic configuration, and that is true. It depends on electronic configuration. So that's true. So as you can see, I just explained. Also, please note number two. Number two, number two, please. Number two, according to periodic law, number two, please. According to periodic law, according to periodic law, the outermost electron configuration of an atom, the outermost electron configuration of an atom, recycle periodically, recycle periodically. That is I dot E. That is, if you observe carbon, and observe silicon, carbon and silicon, sorry, carbon and silicon, they both possess four valence electron, right? They both possess what there? Four valence electron, right? So that is the concept behind. So I can say that carbon and silicon possess what? Periodicity. Why? Because they both have four valence electron. That's why it said that note that according to periodic law, the outermost electronic configuration of atom recycle periodically. Right? Number three. Number three, please. Any property of an atom, any property of an atom that varies with the electronic configuration. I said any property of an atom that varies with the electronic configuration exhibits periodicity. Exhibit periodicity. All right. So I've given you the three important things to note as you study the concept of periodicity. At this junction here, let's look at periodic properties. Properties of periodicity. Periodic properties. All right. Let's look at the concept of periodic properties. Periodic properties. Let's look at periodic properties. right? So let's do periodic properties. Let's do periodic properties. All right. So let's do periodic um, periodic properties. So let's do periodic properties. By definition, please. Definition, please. Periodic properties are the properties that shows periodicity. Periodic properties are the properties that shows periodicity on a periodic table. I said the properties of the periodic properties. The periodic properties are the properties that shows periodicity in periodic table, right? So that's like how you define the concept of periodicity, right? At this junction, what are now or what are that property or what are the properties of periodicity? They are so many numbers. So number one, please. Properties, please. Number one, we have the atomic size. Atomic size. All right. Number two, we have the atomic volume. Atomic volume. Number three, there we have the ionic radius. Ionic radius. Number four, we have ionization energy. Ionization energy. All right. Number five, we have electron affinity. Electron affinity. All right. We also have electropositivity. Electropositivity. And also we have number seven. We have electronegativity. All right. These are the seven properties of um, periodic property or periodicity. So there are seven number. We have the atomic size, atomic volume, ionic radius, um, ionization energy. We have electron affinity. We have electron positivity, and we have electronegativity. We'll look at them one by one. Listen, we'll look at them one by one. We'll start with this, then this, one by one. Trust me, right? Look at them one by one in our next video, right? So it means that for this topic here, we'll look at this is my first video, this second video, third, fourth, fifth, sixth, seventh, and eighth video, right? So I'll separate. I won't combine. I want them to be understood. So I'll take it my time to explain each of them in 8 videos, right? Because I will work on that place. All right. Having said this, look at this next class. In our next class, look at them one after the other. Before we go, let's do some examples, please. Let's solve some past questions. Sample problem, please. Let's do some sample problem. Sample problems. Sample problems. Let's solve some questions, please. Number one, please. Let's solve some questions. Number one. It says, which of the following properties of atom exhibit periodicity? Which of the following property of an atom exhibits periodicity? Number one, please. Density and pressure. Number two, atomic size and ionization energy. Number three, melting point and boiling point. Number four, let's look at it. D, volume and weight. Of course, my answer here is atomic size and ionization energy. These two exhibit periodicity. All right. But question two says Which of the following does not exhibit periodicity? Which of the following does not exhibit periodicity? Option 1, electronegativity. Option 2, ionization energy. Option 3, ionic radius. Option 4, atomic weight. Of course, it says which of the following exhibits periodicity. Number 1 there was what? Electronegativity. Yes, it's here. So it exhibits periodicity. Number 2 says ionization energy, right? That one also exhibits periodicity. It says also ionic radius. Of course, ionic radius is here, also exhibits periodicity. What again there? The last one was atomic weight. Atomic weight is not here, so it does not exhibit. And the question says which of the following does not. So it means my answer is option D. Next one says the term periodicity refers to. The term periodicity refers to option A, the repeated occurrence of specific properties of elements based on electronic configuration. Option B says the change in the element atom mass over time. Option C says the chemical stability of elements in a given periodic table. Option D says the consistent size of atom in the periodic table. So which of them is my answer? Of course, you said this question says the term periodicity refers to. Option A is my answer. What's option A? It says the repeated occurrence of specific properties of elements based on electronic configuration. So my answer is option D. Option A, sorry, for this particular question. So in the next class, we'll look at the concept of atomic size. Please, by the way, I can call it atomic size or I call it atomic radius. So either of the two. So I'll call it atomic size or atomic radius. We'll look at this first one in our next class. If you find this class helpful, do well to like this video, share to your friends and classmates. Also, do subscribe to my channel, leave a comment, and also, do well to keep on watching the videos, keep on learning. So the more you learn, the more you earn. Your learning ability is determined by your learning ability is determined by your earning capability. So see you guys in this class. So also do well to follow my WhatsApp channel and WhatsApp group. I'll leave the link to my WhatsApp channel, WhatsApp group in the video description. So you see a video description. So you can check the link on our WhatsApp channel and our WhatsApp group there. And also, if you want a personal tutorial with me, a one-on-one class with me, you can reach out to me so we can discuss on the price and then we'll start class with you. And also, if you're interested in learning about artificial intelligence, AI, to create videos on YouTube, right? You want to learn how to create the video I'm displaying on the screen, this kind of videos. I did them myself. If you want to learn about those things, you can reach out to me on my WhatsApp. So I want to learn about AI, right? So I have an AI community where I teach people how to create videos using AI.
Imagine a city so powerful, so strategically placed, that every empire in the known world either wanted to own it or feared whoever did. A city that stood for over 1,000 years, survived dozens of sieges, outlived the
viral videos using AI. If you're interested, you can reach out to me and we get your work done. Alright guys, see you in the next video and welcome to Excellent Link Academy.